Johnny decides, rather than do this, he's going to increase each monthly deposit by 2%. He's going to increase each monthly deposit by 2%. So he's not going to keep on putting 100 in. The first increase is in the second month. So the first time he gives 100. The next time he's going to give 100 times plus 2%. And the next one, 100 plus 2% plus 2% again, and so on. Okay? So then they want us to build the series again, find an expression instead of a of n, they call it b of n, and then find the value after 24 months. Okay? So let's have a go at this. And this is tricky because this approach is not going to work. Okay? What's going wrong? I'm going to get rid of this. I need some more space. Let's build it from scratch this time because this is where it gets different. And it's this is either last or second last question in a paper, so it's meant to be hard. We're talking instead of A's, we've got B's. Okay, so B1. He still puts in his first amount just like he did before. Okay? And he still gets the same amount of interest. That hasn't changed. Okay? But what happens next month? He's going to take this amount, right? That's B1. And then he's going to put in a new deposit, and then all of that will get interest. Okay? But the thing is, his new deposit isn't the same size as his first deposit, right? It's 100, and because it's 2% bigger, I multiply by 1.02, right? And all of that gets interest. Okay? So, let's just simplify out our terms. 100, 1.0025 squared, because it's got two lots now. And then this is the second deposit he made, here on the end. Okay, B3. I'm going to build it the same way, right? So it's the previous amount plus a new deposit. But this deposit is bigger again. It's 2% bigger, right? So it'll be 100 times what? If it's 2% larger another time, right? I multiplied it by 1.02 to make it 2% bigger once, so I'll do it again. 1.02 squared. Okay? And then all of that gets its interest. Okay? So now I'm going to substitute out for my B2. So I've got this $100, which was his first deposit. It's got 3 lots. Then I've got his second deposit, which was a bit bigger, but it's got less interest on it. Okay? And then I've got the most recent deposit, which was the biggest deposit of the lot. See, that's the 1.02 squared, but it has the least amount of interest on it. Now, this is confusing for us, right? Because as you start to build the series, you can see it's not quite as simple as it was before, okay? Now, in my working, I think just to be sure, I did B4. Okay, because this is unusual for us, right? It's got some different things in it. So what would happen? Well, I'll skip a line. I'll just go immediately to what it's equal to. That first lot, right, it's going to get one more lot of interest. So 4 lots of interest. Then this next one, which was bigger by 2%, gets another lot of interest. Then this one will get another lot of interest. And then he'll have his last, most recent and largest deposit. Namely, it's got 3 lots of that 2% increase, plus 1 lot of interest. Okay? I'm trying to get across to you what each bit is so that you're not just mindlessly putting all these indices together, but you know what each bit means. Okay? So what's B of n? You can see you can actually still take out a factor of 100. So that's good. 100 out the front. Okay. What's the first one after you take the factor of 100 out? Well, it wasn't bigger. It just got the interest on and on and on and on. How many lots of interest would it have? Well, this first one had 1 lot of interest. And after the second month, it had 2 lots of interest. Every month, it's getting 1 lot. So after n months, it'll have n lots of interest on it. Okay. But the next one, right? It's got less interest, but it starts out bigger, right? So it starts out bigger by 2%. I'm putting that 1 there because it means I can skip a multiplication sign. And it'll be useful for me later when I'm counting. But it's got 1 lot less of interest, so that's n minus 1. See that? Okay, the next one, it's bigger to start with. So that's the 1.02 squared. But again, it's been in there for less amount of time, so it's got less interest on it. Namely, n minus 2 lots of interest. Okay? And then the series goes on. What will the last one be? Look at the pattern we've built. This is why it's so important to do this part, right? The last part will be the biggest of all, okay, in terms of how big it was when it started. This number here, 3, and this number here, 2, and this number here, 1, okay, indicates that. This will be 1.02 to the power of n minus 1, right? You can see it's always 1 short of what b is, okay? And then it's still got 1 lot of interest on it. Okay, we're almost there. Now this is why I tried to draw out the fact that when you're thinking about your first term, whichever way you look at it, when you look at it forwards or backwards, your first term is going to have some n's in it, okay? It's either going to have this n or it's going to have this n, okay? You can't avoid it, but that's okay, right? This is a GP, and its A is, its first term is, well, big term. We can start at the front, we can start at the end, it doesn't matter. I guess I'll pick this one because it's a bit simpler than this one. It's only got 1 term in it. So here's my A. Okay? Watch the N. Crucially important. Okay? What's the ratio? Now, we're used to things just going, I've got 1 lot, now I've got 2, now I've got 3. What's happening? As you go from one to another, you get an extra lot of 1.02. But then you get 1 less of this interest, right? 1.025. So you're multiplying by 1.02, but you are dividing at the same time by 1.0025. Of course, if I started this A at the other end, this would be upside down, because I'm going in a different direction. How many terms? B1 has 1 term, B2 has 2 terms, B3 has 3 terms. I think B of n, and you can count it out actually, this is why I put the 1s in there, right? I've got 1 here, then 2, 3, 4, 5, all the way up into n. So there are n terms. So therefore, when I put this into my GP formula, my sum formula, okay, I've got the 100 still hanging out the front, times my A, which has an n in it, but that's okay, times R, which is this fraction, all to the power of n, minus 1. Okay? And that's all divided by R minus 1, which is this. Whatever that is. Okay? Now, I think I actually wrote down what it is because it'll make our fraction just a little bit neater. But it's a weird fraction. It's like 400 and something. Okay, what have I got? Now, this 100, have a think about, sorry, out the front. Have a think about this because we can make this a little neater. See, you've got 1.0025 to the power of n. You also have 1.0025 to the power of n here, right? But it's dividing. So when I multiply this by this, what you'll be left with is 1.02 to the power of n. You see how those two are cancelling out? And then this just comes along on the end here. So I've got 1.0025 to the n. Then you got 2 n's there. That's a bit weird. It does make it very hard to solve if you were trying to find out an n. But the question we're asking for is after a certain amount of time. Okay. Now I should just finish off. This fraction down the bottom ends up being 7 on 401 if you chuck it into your calculator. Okay. So that 401 I'll just put at the top on 7. Ta-da! And that's all the hard legwork. Okay? Now I think the very last question is, so therefore tell me, how much does he have? What's the value of b when n is 24? So after 2 years, okay? And all you have to do is take your 24 and chuck it in here and here. You chuck it in 2 spots, which is a bit unusual compared to what we usually do. but it still works, okay, and the numbers still check out. The thing you have to be careful for is this, I think. Okay.